Jamb 2026 candidates, welcome to today's calculation lesson, and we are treating echo problems under echo. All right, please, if you need assistance, especially last-minute preparation assistance, do not hesitate. Do not hesitate to contact me. Okay, let me help you. Okay, it is never too late. Okay, I can still help you. If I can do it in 72 hours, I can do it within 1 week. I can do it within 5 days. I can do it within 2 weeks. I can do it within 1 month. So ensure to send me a message. We have materials available. Materials such as last-minute preparation plan, which is a plan that allows you to do less and score more. And we also have short and concise lesson note that covers the Jamb UTME syllabus. This Jamb 2026 syllabus, it covers everything and it's very, very short. Okay, very short notes. Okay, available on physics, chemistry, biology, and English. So ensure to get a copy. The book is also available, the strategic book to blast Jamb 72 hours to Jamb UTME. Also get that one. And the list of calculation topics where Jamb is going to set calculation questions from. That's where we are selecting all these topics from. And we are treating them, especially the high hits, the most repeated among them. Okay, that's what we are treating regularly. And now we are looking at echo problem. We are almost done with the high hit. Immediately we are done with the high hit. We are going to finish the high hit this week. And we are entering chemistry next week. So at exactly on the 14th of March, we are going to start treating chemistry calculation. Chemistry calculation is very short. And some of the calculation in chemistry, we've already treated them in physics because some topics are shared between physics and chemistry. So chemistry is very short. Chemistry will not take more than 1 week to complete. All right, 1 week or 8 or 9 days. All right, we don't take. So we have enough time for our exploratory studies, for past questions, and also for more Jamb must repeat questions, about 800 that I'm going to release on the 1st of April 2026. Jamb 2026 candidates, the question we have here under echo problem. Jamb must repeat question 1 under echo problem. The question reads: a man hears his echo from nearby hill 2 seconds after he shouted. So he heard this echo 2 seconds after he did what? After he what? He shouted. That was when he heard the echo. Now let's quickly put that one here first. They give us time equal to seconds, 2 seconds. Okay, that's the time given. Okay, if frequency of his voice is 260 hertz, frequency F is equal to 260 hertz. Okay, and the wavelength is 1.29 meters, and the wavelength is what? 1 lambda is equal to 1.29 meters. Okay, how far away is the hill? How far away is the hill? So it's asking us how far. So it's asking us the distance. Okay, the distance of the hill. How far? The distance. The distance of the hill is equal to what? What's the distance of the hill? So that's what we are looking for. All right, that's what they told us to find. Okay, so we look at the options provided. They are all represented in some day centimeter, some day meter. Like this one now, day centimeter, 660.0 centimeter. The rest day meters. Okay, so waiting we go do now. What are we going to do next? Understanding this question, the man hears his echo from nearby hill 2 seconds after he shouted. So he shouted and there was a rebound. Okay, there was a rebound. He heard his echo again. So the echo traveled to and fro. Okay, go and come, going and coming. Okay, it's just like transport. You go Lagos, you come back. You go Abuja, you return. For the man to hear that echo, it shows that there was a rebound. Okay, as he shouts, the thing, you know, echo is defined as the reflection of sound wave on a plane surface. The sound reflects on a plane surface and it hits the plane surface and it rebounds back to the man. So now double journey. Okay, go and come. So that should tell us that it's times 2. So echo travels to and fro. That's going and coming. Okay, to the obstacle. And what is that obstacle? According to the definition I just gave you now, the obstacle is the plane surface. Okay, it hits the plane surface. Just like I say, I'm facing this paper, and I shout to the paper. My voice falls on this. The wave from my voice falls on this paper, and it rebounds back and enters my ear, and I perceive it as sound, an echo of what I am saying, or an echo of my voice. You understand? Okay. So this technically means that since we have a to and fro movement, it's going to be times 2 the distance. Okay, that's times 2 the distance. Times 2 the distance. All right. As I did here like this, it be like say my head scatter. I don't even know the formula I want to apply here to find this distance. Okay. But let's write out some formula that I can remember right now. First of all, let me just be writing the formula. Okay. If I remember better formula, we will work. I will use them. Okay. V, which is velocity, is equal to, man, what I will derive, frequency times lambda. Okay. V, which is velocity, is equal to frequency times lambda. Velocity, get any formula again? I don't think so. I don't think so. Okay, the formula of distance is equal to v, velocity times lambda, times time. Okay, so d now is equal to velocity times time. So this is the formula for distance, velocity times time. Okay, that's the formula for distance. Okay, so remember we have to find speed. Okay, we have to find the speed of the sound, which is the velocity. Remember, speed is equal to velocity. Remember, speed is equal to what? Velocity. They get the same unit. Speed and velocity get the same unit. Meter per second. Meter per second. Now the same unit. So they are the same. What is the formula for speed? Alright? Or the formula for velocity? What's the formula? The formula of velocity. What's the formula? Meter per second. But if you look what they give us, all the parameters given to us, we don't have distance there. Now distance we even define. Now only time there. So now this one we will use. Okay? For wave, velocity is equal to frequency times lambda. Okay, so we have frequency and we have lambda. So let's quickly solve that. Okay, so velocity is equal to frequency lambda. Okay, where our v is equal to, what's our frequency? Our frequency is 260 times, what's our wavelength? 1.29. Okay, and this will give us, if you times it, 335.4 meter per second velocity. That's what we are looking for. All right, so now we have velocity. V now is equal to 335.4 meter per second. Okay, so that's our velocity. So remember, velocity is also speed. Okay, so the time, we have to work on the time. What is the formula for time? The formula of time is t is equal to t over circle. So this is the formula for time. So when you are looking for time, okay, or you want to modify time according to the time given to you, because we have more than one time here, we have to calculate the second according to the echo pattern. Okay, so this will now give us equal to, what is the value of t? The value of t is 2 seconds, which is 2 over, what is the circle? The circle covered by the echo times 2 the distance, which is 2 times 2 over 2. This into this will give us equal to 1 second. Okay, so the new time now is now 1 second. All right, so we now have another time here now, t, capital letter T equal to 1 second. Okay, not small letter t again, capital letter T. So what next? What next? The next thing we are going to do now is to calculate the distance. Let's see if we can apply this formula now. Yes, we can. We can now apply this formula because we were looking for this velocity. We were able to find velocity. Look at it. Okay, because we didn't have velocity, we had to find velocity, and now we have found time because that's what is missing in the parameter. Therefore, d is equal to vt. D, which is the distance of the hill, is equal to, velocity is what? 335.4 times what? Time. Our time is 1. D is equal to 335.4 meters. Okay, meters. All right. So what's the answer among the options provided? Pick the answer and drop the answer in the comment section. We are still under echo problem. Okay, anytime you see these 3 dots after a subtopic, just know that we are still under that topic. Okay, it's like continuation of the topic. Okay, please, if you need any assistance, please, this is my connect me now, make I help you, make you no write this Jamb again. You go regret them. If you lose guard again this year, you go regret them. Anyway, I will always be there to teach you. Okay, I will always be there to teach you. If you say you don't want to pass on this year, say now next year you want serious, we go run on next year. While I know that I'm always active. Okay, but I will advise you, the last minute preparation plan is there to help you. Please get the last minute preparation plan and all the small materials where you need. Small money, that money where you want to pay that upgrader scammer and that foolish scammer Jamb expo people where you say no go do anything for you. Bring small money inside. I hear say when they pay them 20k, 30k, 40k, 50k. Bring small money for inside. Purchase this last minute preparation plan. Pass your Jamb easily. I have all the lessons available to you for free. You will access all the lessons for free. Like this one now where you take for free. Make your decision. Oh, this is not my contact. Make your decision. All right. So under echo problem, let's look at most likely questions in Jamb UTME 2026 under this echo problem. Okay, how Jamb take the setup and the kind of formula where you need to take follow them. The first I would like to talk about is echo distance. Echo distance is equal to v. Okay, this one is the velocity of echo over 2. Is it actually velocity of echo? Velocity times time. So let me expand it so that you will understand better. Equal to velocity times echo time over 2. Okay, so this one is the echo distance. If they tell you say you find echo distance, now this formula you go apply. Okay, if they ask you say speed, okay, speed of sound is known as v, or velocity of sound, is equal to fs lambda. Okay, s is wave number, lambda is wavelength, f is frequency. Okay, so we don't already treat them before for progressive wave. So The next one, first to fifth harmonics. First to fifth harmonics for open pipe, open pipe own. Open pipe. First to fifth harmonics for open pipe include, look at the list here. The list include 1F, 2F, 3F, 4F, 5F, and so on and so forth. So just know that first to fifth harmonics for open pipe, or the harmonics for open pipe, is all the numbers, both odd and even. All the numbers 1, 2, 3, 4, all the numbers of frequency, 1 frequency, 2 frequency, 3 frequency, 4 frequency, 5 frequency, know that one. Then first to fifth harmonics for closed pipe own, closed pipe own are all the odd number, okay? All the odd number, which is 1F, 3F, all the odd number, 5F, 7F, and so on and so forth, even 9F, or just noting an odd number, all the what? Odd number for waiting, close pipe. First overtone, we'll do overtone now. First overtone in open harmonics. First overtone in open harmonics is equal to second harmonics. First overtone in closed harmonics. First overtone in closed harmonic is equal to what? Third harmonics. So guys, let's look at harmonics pipe. We have the closed and open harmonics pipe. But first of all, let's look at the open harmonics pipe first. Okay, we have taught this before, we've discussed this before. When you look at our previous lessons, we've discussed the open and the closed harmonic pipe. Okay, but let me just, for the sake of these calculation questions, let me just, refresh our memory. Okay, so for the open harmonics pipe, let me write it, open pipe. Okay, open pipe. For the open pipe, you have something like this. You will see something like this. Okay, see something like this, something like this. Okay, so any pipe you see that is open, the two end is open, nothing is covering it. Okay, this place now that you have this intersection here is called what? The node. Okay, this is called the node. While here, this open place is called what? The antinode. The antinode. You know the meaning of anti, right? Antinode. There's no blockade. Okay, so in other words, the open pipe is a kind of pipe where the node or the blockade is in the middle. It's not at the extreme of the pipe. That's the pipe, the end. When you are talking about closed or open pipe, you are talking about the end. Is the end open or the end is closed? Okay, both end, the opposite end. Okay, then let me give you the formula for open pipe. Okay, the formula for calculating open pipe. Open pipe, you calculate the frequency. Okay, frequency of the pipe is equal to, we are going to have NV over 2L. All right, where this n here, n here is equal to the what? The frequency. So the frequency of the harmonics. Okay, the frequency of the what? Harmonics. I taught you harmonics already. Look at the harmonics we are talking about for first to fifth harmonic for open pipe. So is this frequency you are talking about? Look at the frequency here, F1, F2, F3, F4, and so on and so forth. So n is equal to what? The frequency of the harmonics. Okay, which is this, the harmonics, or let's say it's equal to the harmonics. Okay, this is for open pipe. Okay, let's look at closed pipe. Okay, closed pipe. Okay, unlike the open pipe, I know you are able to draw the closed pipe yourself now. In closed pipe, you have something like this. You now have something like this. Okay, you can see that here one of the end is blocked. So here that is blocked will now be called what? Here we call here what? The node. Okay, the node. Then here is called the antinode. All this place, all this part is called what? The antinode. Okay, the antinode. All right, so what is the formula for closed pipe? All right, you can see that one end is blocked. Okay, that's how you differentiate closed and open pipe. The formula for closed pipe is F is equal to N V over 4L, where L is equal to length, V is equal to velocity, N here, N is equal to what? The frequency of the what? The harmonics. Okay, harmonics. This one for closed pipe. Remember all the odd numbers. Okay, from first to fifth harmonics for closed pipe, all the odd numbers: 1, 3, 5, 7, 9, and so on and so forth. So if you want to say the first harmonics of, I've taught this before, the first harmonic for closed pipe is F1, okay, or 1F. That's the first harmonic. The second harmonics is 3F. The third harmonics is 5F. But in open pipe, the first harmonic is 1F, the second is 2F, the third is 3F, and so on and so forth. Make you follow, make mistake. Let's quickly take a question under echo to further illustrate what we have learned. So this is an echo problem from Jamb past question that Jamb always repeats almost every year. Jamb must repeat question 2, other echo problem. The question reads, an organ pipe emits a fundamental note of frequency 128 Hz. On blowing into it more strongly, it produces the first overtone of frequency 384 Hz. What is the type of pipe? Okay, first of all, what do? You look at the option. Among the options, what was given? The options are A, open pipe, B, closed pipe, C, both, D, cannot be determined. Okay, so how do we pick the correct option here now? All right, so to determine this, according to what we have just learned, first of all, let's figure out what we were told to find. What is the type of the pipe? We were told to find the type of the pipe. So given the type of the pipe, type of pipe, okay, is equal to question mark. So this is what we are looking for. All right, so let's now look at what they gave us to solve. An organ emits a fundamental note of frequency. So this is the fundamental frequency. So fundamental frequency, F frequency, let's put it like this, F frequency, which is fundamental frequency, is equal to 128 Hz. Okay, on blowing into it more strongly, it produces its first overtone of frequency 384 Hz. Okay, overtone frequency, that's FO, equal to what? 384 Hz. Okay, so with this now, they told us to find what? The type of the pipe. Okay, for us to figure out the type of pipe, first of all, we look at the frequencies. All of them are represented in Hz, so no need for conversion or anything. So all of them are represented in Hz. To find the type of pipe, to detect type of pipe using frequency, you use the formula overtone frequency over fundamental frequency. Okay, overtone frequency over fundamental frequency. Okay, that's the formula. So if we substitute, equal to, we are going to have overtone frequency, which is 384 over the fundamental frequency, which is 128. Okay, so when we divide this, you divide this by this, it's going to give us what? 128 divided by 384. Is that not 3? That should give us 3. So equal to 3 Hz. So with this, our answer 3. How do we use it to find the type of the pipe? Remember what we just learned, what I just taught you. That the first to fifth harmonics for the what? Open pipe is what? You know the numbers, right? Then the first to fifth harmonics for the closed pipe is what? You know the numbers, right? So 3, since 3 is our answer, how do we find out if it's a closed pipe or open pipe? We use the harmonics. So this one is our harmonics now. So n is equal to 3. This is the harmonic. So therefore, the pipe type is what? What pipe type should it be? Drop it in the comment section. Okay, pick the correct option. Since it's 3 and 3 is an odd number, okay, odd number. So pick the correct option among the options provided and drop it in the comment section. I want to be very sure that you understood this echo problem. All right, see you in the next class. Jamb 2026 candidates.